Welcome, ladies and gentlemen, boys and girls. Today we're going to solve another curious problem, which is binary tree tilt. So we have to tilt the binary tree. The heading will make you some nonsense, like you feel are kind of nonsense, but the question will give you all the sense. So let's talk about the question. So the question thing, like we're given the root of a binary tree and written the sum of every tree node's tilt. Okay, the tilt of a tree node is the absolute difference between sum of all the left subtree node value and all the right subtree node value. Okay, so what it's saying, the tilt will be is something like left node value, left value minus right value. So it's saying something like this, right node value. Okay, if a node does not have a left child, the sum of the right will be node value 0. Okay, so if let's say it don't have a left or right side, then we will give as 0. Okay, the rule is similar. Okay, so this one is example test case, very simple. So I will talk you about the another test case. Okay, so let's talk about the example 2. So this will definitely going to understand what the question is saying. Okay, so ladies and gentlemen, what the question is saying, like according to the given condition, what I have to do, I have to check it from the below side, bottom side. Okay, so what I will do, I will check in my 3. Does my 3, I will write over here, does my 3 has any left or right? No, it will be 0 minus 0. So the difference will be 0. So the tilt will become 0 over here. As you see, the 0 come over here. About the tilt, I will talk about later on. First of all, let's just see like what the question is saying. Or I just write it over here as well. Okay. Now let's talk about a 5. So 5, it doesn't have left, not right. 0, 7, 0, 0, 0, 0. Okay, ladies and gentlemen. Now let's talk about 2. 2 has something interesting. 3 minus 5, which will be 2. Now you say minus 2. I will say we have to give the absolute difference. Okay. Now let's talk about 9. 9. So 9 will be 0 minus 7, which will be 7. Okay. So what's the tilt values coming over here? The 3 will become 0. The 5 will become 0. If you see, the 7 will become 0. And our 2 will be 2 because still, 3 minus 5 is 2. And the 9 will become 7. The 9 will become 7. You see, 0 minus 7 is still 7. Okay. Now let's talk about 4. For the 4, how we get? So I have to add this together. So it will be 2 plus 3 plus 5, all the left value minus all the right value. 9 plus 7, which will be something like 9 plus 7 is like, I will write that over here. So it will give something like 10 minus 16, which will be 6. So this will be 6 over here. So it will come 6 over here. So I hope so now you understand like how the 6 is coming over here on the tilt. So that's what we have to do. And finally, I have to return the tilt sum. The tilt sum over here. So the tilt sum will be 6 plus 7 is 13 plus 2 is 15. So I have to give left value plus right value of this tilt plus the root value. So which will be 15. I hope so, ladies and gentlemen, that this is making some sense. What the logic is saying, what the question is saying. Now let's talk about how we're going to solve this problem, ladies and gentlemen. That's the main thing over here is. So to solve this problem, I will suggest like, why don't we use post order traversal to solve this question? So that will be a great thing to do. So what I will do, I will initially create my sum. My sum will be initially 0. So the sum will hold the value of the tilt one. Okay, and initially 0. Okay. Now what I will do, I will use a post order traversal. So I will make a call over here to my post order. Then it will go for the roots. Then first of all, it will go for its left. Then it will go for the right. And then what it will do, it will get the absolute difference. The sum will get the absolute difference of absolute of left minus right. I hope it's clear. And finally, I will return my left plus right plus root value. The code is simple. The approach is making some sense to you. If you still don't understand, don't worry, ladies and gentlemen. Now we are solving the problem using a code. So if you still don't understand anything, you will understand over here. So ladies and gentlemen, first of all, what I will do, I will initialize my sum as a global variable over here. It's initially 0. Okay, ladies and gentlemen. Now what I will do, I will say, okay, do one thing. Let me make a call to my post order, and it will traverse on my root on the complete tree. Okay, and then I will finally return my sum over here. So that's all the code for this public function is this function. Now I will work for my post order function over here. Okay, ladies and gentlemen. So yeah, now what I will do over here. So first of all, I will just give a base condition. My base condition will say if my root is null, then simply return 0. Okay, this is our base condition. I will just give a base code. Now I will traverse on its left. So how it go for the left? I will say, okay, do one thing. Use my post order function and traverse. is root dot left. Go till the maximum depth. And similar for the right as well. Post order of root dot right. I hope, ladies and gentlemen, the cost is clear what I'm doing over here. Now what I will do, I will add to my sum. I will update it using math dot absolute difference of my left minus right. Okay, guys. So that's how I will get my tilt value. So using that, I will get my tilt value, and finally I have to return what? I have to return my left value plus right value as an output plus what? Root value. Root 12. And ladies and gentlemen, that's all the code is. Let me just give a quick run here to see if we are facing any compilation error. I hope so, like we don't face, but still, let's see, because mistakes happens. And I hope the code is clear. What is saying, like, okay, I get something over here. Return left dot 12. Okay, ladies and gentlemen, so by mistake, I just did this mistake. Let's get val dot 12 over here. Mistakes happen. That's why. I don't know, my mind is somewhere else. Okay, so it's accepting well, ladies and gentlemen. So let me just submit this code to talk about what's the time complexity and space complexity in this. And here we go, ladies and gentlemen, it's accepting well. So I know the code is clear and the logic approach, everything is clear. The time complexity in this one is we are dealing with big of n. Why? Because we are recursively traversing all the nodes only once time, n number of nodes for the worst case. That's why time complexity is big of n, and the space complexity is big of n as well. Why? Because still we are using a constant size variable, but the thing is, like, it consumes additional memory in a function called stack. So because of that, because we are declaring our this variable as a globally, so that's why. So space complexity big of, and I also, ladies and gentlemen, now everything is clear. So if you still have any doubt, I will say just do let me know in the comment section. I will definitely gonna reach to you. And thank you so much, ladies and gentlemen, for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Believe me, I love you. Take care, bye bye. And till then, listen to this song.